In this model, we are going to discuss about the transfer of heat, especially for conduction phenomena. So heat is a one form of energy. The heat is to be transferred from higher temperature side to lower temperature side. That the transfer of heat are going to take place in three ways. One is for conduction. Conduction is nothing but the heat is to be conducted through one atom to another atom. Okay, and another that's conduction of heat is possible from solids, liquid, and gases. And also the next idea is called the convection. Convection is the heat is to be transferred from one layer to another layer. That's transferred from one layer to another layer. The convection also happening in liquids and gases. Radiation is one of the particular process. It should have takes place the transfer media is not available. It should takes place as an electromagnetic wave. Okay, that is also takes place in a gases only. Okay, so in this way we can discuss only the main concept in conduction in this model. Let us discuss today introduction about the transfer of heat, especially for conduction, followed by what is called mean by thermal conductivity, and a conclusion of this particular model. Yeah. First of all, what is mean by conduction? Heat is transmitted from one place to another place in three ways. Already we mentioned about this conduction, convection, and radiation. Conduction is nothing but conduction of heat may be defined as a flow of heat through unequally heated body from place of higher temperature places to lower temperature. That's heat flow from unequally heated body. Unequally heated from body from one area, one point to another point. So it should be takes place on all three matters, all solids like liquids and gases. Suppose when one end of the metal is heated, the other end soon becomes warm. The heat is to be conducted through the rod. That we have confirmed it. The heat is to be conducted through the rod. Okay, so let us detail discuss how detail discuss about the conduction phenomena. So consider in this figure we consider the one particular slab of material with the length x. Thus we have to consider the cubical box of length x and the area of cross section A. The opposite faces are maintained at two different temperature. That point is going to be a hot in left hand side. Right hand side theta 2 is fixed as a cold comparatively is lesser heat than theta 1. Theta 1 is greater than theta 2. As in that there is no heat flow from the other side of this slab. Okay. Then the quantity of heat Q is conducted from one phase to another phase. So what are the possibility to conducting the heat? What are the favorable quantity of the heat conduction is one is directly proportional to area of cross section. The directly proportional to the difference of temperature of the two media theta 1 minus theta 2, okay, and directly proportional to the time quantity and inversely proportional to the length x. So if your thickness is very lesser, it's commonly the heat is to be conducted fastly. Thickness of the layer is very high. Yeah, the flow of heat flow is going to slow. When the total energy is directly proportional to the considered above the considered quantity is directly proportional to A into theta 1 minus theta 2 into T. These are the proportional quantities and inverse proportional quantity is nothing but a X. Here you got putting in one particular constant called thermal conductivity K. K is equal to A into theta 1 minus theta 2 into T by X. Here, Q is called a coefficient of thermal conductivity of the material of the slab of the disk. After we can define that quantity, but Q is nothing but total energy gained by the system from place to 1 to 2. The quantity theta 1 minus theta 2 by x is represent the rate of fall of temperature with respect to the distance, that is called the temperature gradient. For small thickness of the slab and a small temperature difference, we can take the temperature gradient as d theta by dx, since it represents the fall of temperature with the distance. The d theta by dx is going to be a negative quantity. Automatically, the total energy transfer is Q is equal to Ka d theta by dx into T. So here, if you were to putting an ideal quantity, A is a 1 meter square, theta d theta by dx is 1, T equal to 1 second. The total energy transfer from one place to another place is nothing but thermal conductivity. So from this idea, we can define the thermal conductivity of the material is defined as numerically equal to the quantity of heat conducted per second normally across the unit area of cross section of the material per unit temperature gradient. Okay. Therefore, that you understood very easily. The thermal conductivity of the metal is defined as numerically equal to the quantity of heat conducted per second across a unit area cross section under the material per unit temperature gradient. But K is equal to watt per meter per minus 1 Kelvin per minus 1. This is the unit of thermal conductivity. So finally, you come to the conclusion of that particular part. Here, first of all, we discuss about the transfer of heat. The transfer of heat in the solids, liquids, and gases. There will be a three ways of transfer of heat has been taken place. This with conduction, convection, radiation. Conduction has happening in all three state of material matter, and convection and radiation is to be has been taken place only for liquids and gases, because the molecules should be in molecular position is be less bounded and randomly oriented in gases, but solid molecule, the molecule is going to arranged closely. Okay, so here we got to, in this part we discussed in detail about the conduction. The conduction is one of particular phenomena from the heat is to be conducted from higher temperature to the temperature side to the lower temperature side. So in the inside the one particular cubical boxes of length x, area cross section A, here we maintaining the temperature theta 1, theta 2 is going to be higher compared to another end of this called cold. But therefore the difference of temperature is flow from left side to right hand side. There is a what is a favorable quantity of the heat conducted per second. Heat conducted through that material is only is area cross section. Another one is the temperature gradient. The temperature gradient is called theta 1 minus theta 2 by x. The rate of difference temperature with respect to length. But therefore, d theta by dx is a negative quantity. The d theta by dx is just a directly proportional to a, and the time is a directly proportional quantity, and the thickness is a inversely proportional quantity. So from that we can define the thermal conductivity of the material is the total energy transfer from one place to another, heat conducted through the particular material per unit temperature gradient per unit area. Okay, under the 1 second is called the thermal conductivity of the material thermal conductivity of the material of the property. Okay, so with these conclusions, I finished my talk. Thank you.